actor in that array can be a different polymorphic subset of this actor type. Um, so really anything that has this renderable A here.
Sorry, Kyle. I just restarted the recording. Do you want to or just started the recording? Do you mind just
Sure.
repeating that?
And just do a quick recap. Yep. Okay, so for today, we're currently looking at getting the paddle rendering as well as having the paddle respond to user input and having the ball respond to physics. So effectively, we've got an area where these two, the paddle and the ball, share functionality as well as areas where they differ in functionality. And so in order to kind of have the best of both worlds, be able to treat actors as actors, but then also know based on which type of actor they are, run certain functions. That's kind of what we're going to do today. And in order to have multiple different types within the same array, because in Haskell, lists are homogeneous by default. And so in order to make them like polymorphic and expect multiple things, we need to use what's called an existential. And so we're basically making it forget about this A at compile time. So all that this really cares about at runtime is that there's a bunch of actors, but at compile time, it knows that this is an actor paddle, this is an actor ball, right? And this is an actor paddle.
But
But
yeah,
at compile,
that argument is just hidden at compile time.
this argument here, we just hide it because this is actually not, you're not allowed to do this from in Haskell because lists are homogeneous, right? And if we look at this, this is not a homogeneous list, right? We have actor paddle, but then we have actor ball. That's not the same. However, if we hide it behind this existential, what they call it, an existential wrapper, which is basically just an existential type that does nothing but wrap it, we can basically just, now we can remove this. And when we pass these values in at, or like when we use this function, the compiler at compile time will replace the actor with actor paddle. And so our system is able to recognize this as actor paddle, but we're still able to store them as just plain actors. So that's kind of like how polymorphism, like polymorphic lists work in Haskell. So yeah, let's dive into that a little bit more. So okay, let's see where we're. I think right now we just have some compiler errors that could give us some hints as to what we forgot to do. So. And I need to use data kinds because these.
I think you just mean to remove that.
Remove what? Sorry.
Well, that's just pseudocode you just added in.
Oh, you're right. Sorry. I might still need it. No, yeah, you're right. Yeah, it was trying to think. It was like, what is like actor? I was trying to treat that as a kind. Yeah. Okay, couldn't match type actor with actual type ball. First argument of game state. Okay.
So you just need to use that actor.
Yeah.
Yeah, wrapper.
So let's go. Let's see what we're looking at here. Line 117. We've got paddle. I believe. Yeah. And now, no instance. So you can see, yeah, we're basically just wrapping that now with this actor. Which is like, I think this is honestly probably one of the simplest ways to understand polymorphism. If you were to ask me, like, because like really this is all polymorphism is. Like we have a ball, we have a paddle, and now we're just labeling them as actors. We've specified that in order to do this, this must satisfy some constraints. So we are allowing, like we are constraining our polymorphism. But when you're looking at this visually, I find this very nice to understand in this way that like we're literally just labeling this paddle as an actor. And now that it's labeled as an actor, we can use it throughout our system as if it's just an actor. So anything that's like generic at the actor level, so rendering, maybe an actor can make sound, an actor has a position and a size. These kinds of things, these kinds of concepts are like generic, whereas paddle, for example, paddle responds to input and ball responds to collisions. Or paddle also responds to collisions, but ball responds to collisions in a different way because ball can move and paddle can't. Like it can't move without user input. So there's different constraints that we have on these two types, and that's what we're going to be exploring, is actually making the paddle move and making the ball move as basically just two separate functions that we can logically think through. So let's get this compiling first, so we can see the paddle on the screen, and then we'll get it moving. So what's this here? No instance renderable actor arising from the use of create renderable. Go into rendering to see what we've done here. No instance for renderable actor. Interesting. We don't want. So the reason why this is interesting is because we don't necessarily want an instance of renderable actor. But because we've labeled those both as actors now, he's expecting one.
Can you go to the renderable type class?
Yep. I can explain to you quickly if you're curious about okay, so we've implemented renderable for both ball and paddle.
Mm-hmm.
But now that we've wrapped it in an existential, it's expecting, because like when we're passing this now at compile time, it's renderable actor, not renderable ball or renderable paddle.
I mean, we could always create another instance as well that.
Yeah, that's like what I'm thinking might work. Like you make an instance of renderable actor and then pattern match or something to call the correct. Like I don't know, or like we need to throw away the existential at this point, so that we can call the correct create renderable. Yeah, no, we do need to. This is actually something I haven't run into in Haskell. This cloud thing. Because this is coming down to a like a design thing almost. Like I'm wondering.
Well, how did we write this instance? I guess.
Well, how do we write this instance? And now I'm wondering like whether we need actor. Like I don't know. I guess how would you write this? How would you write this instance? Like if we were to go this way.
Yeah, I'm not too sure.
You know,
I mean, let's try it. But like,
because now you'd have to do. Something like this, right?
Well,
But I don't know.
you would
Yeah, go ahead.
No, like, cause you would have actor, right? You would have maybe like you might have the actor constructor, so you could pattern match on the actor constructor,
Oh, sorry, yeah. Oh,
and then call create renderable on actor.
ah, yes. And that really, I mean, that makes sense to get rid of an existential, right?
Mm-hmm.
So like this might be all right.
You'll need to pass the renderer argument as well, but
Sorry, where?
the renderer, the first argument of create renderable.
Oh, yeah, sorry. Yeah. You're right.
You want to check if that compiles? Because
Yeah.
that might complain about the Skolem type. Oh.
Our rectangle calculation was wrong, but we're close.
Yeah.
All right. We have two different shapes on the screen. This is progress. Wedge pong. We met it. Exactly. Exactly.
This is actually what we wanted.
Yeah, this is a feature, not a bug. Don't worry. Don't worry. Don't ask questions. Don't ask questions that you're not prepared to hear the answer for.
Yes.
All right. Okay. Great. Let's figure out why the heck this triangle is not working correctly, or the rectangle. Shouldn't be too bad. Let's go into the paddle code. This would really be create vertex buffer from verts. That would just be in rendering. Create vertex buffer from verts. I want to trace this. Okay, so I got rid of it. Import debug trace and qualify it as DT. And then, yeah, let's see. That didn't recompile, so that. Anyway. For whatever reason, it doesn't look like it's recompiling on it. So I'm just.
Is the
See what I
file
mean?
saved or?
Yeah.
Yeah.
Maybe the DT trace doesn't trick. That's weird. I don't know what the hell's going on. Let's try like doing something like. Yeah. Okay. Now with bag.
I mean, you could just try printing wherever you call the you could call that create renderable. That might.
Yeah. Well, here it's this. Now it's showing me the correct error.
Oh, it's probably because of the
Yeah.
dollar sign. That looks funny the way you did it.
Yeah. Mm-hmm. Wait, a VM paddle.
Oh, and then put a bracket around make rectangle the second time.
Yeah. That's where I meant to put the dollar sign.
Yes.
Okay, so our verts, we've got. Yeah, that doesn't. Yeah, let's get out. I like to draw. Okay. So we got 0 on the. We'll call this point here 0, 0. So we got 0, 0.4. Let's just call it there. You got 0.1. No, X. So this is. Shoot, my bad. I did it the wrong way. 0, 0.4. Then we need 0.1x. 0.4 is here. Then we've got 0.10. And then 0, 0. So that creates like the rectangle. It's just, I don't know if we're doing that in the right order. I'm honestly just getting Claude to check my vertex order.
Finally using Claude. Let's see.
It's a lot better.
Yes.
In any vertices, they form a rectangle with issues, likely the primitive type you're using and how the vertices order for that type. Current order, if you're using triangle strip, you need this order, which is what we are using. bottom left, bottom right, top left, top right. Okay, so we've just got the order wrong. Let's go to where we did this rectangle vertices thingy. Make rectangle verts. And we just have to reorder these. So we want bottom left, bottom right. So this is bottom left. Then we need bottom right. Then we need top left and top right, which is this. Thank you, Claude.
Good use of AI here, right? We're basically just going through documentation through AI, right?
Give me a second here. I don't know why that's happening. It could be something with the NixGL intel, but it's certain changes that I'm making. It's not recognizing as.
Do you have every module in your Cabal file?
Ooh, no, I don't. Maybe not. We've added modules, so and it is this new module that.
Yeah.
Is that a thing? Yeah.
Oh yeah. So you want to add other modules?
Oh. And what I put in.
Just every other module you have there. So.
Paddle, rendering paddle.
Yeah, basically your directory structure.
Really? Okay. This seems interesting. Okay.
Yeah, like it's good at finding it like usually without it, but like sometimes you'll definitely need it for building. If you're doing a full build.
Yeah. Okay. Maybe the winding order's wrong now.
Are we? Did we change like the culling logic?
Yeah, I'm just gonna check that.
Yeah.
Triangles. Where did I specify triangle strip again?
There's just grep for it.
I am going to. I'm in triangle list. Oh. That'll do it. Triangle strip is more like it's more. I don't know. I'm wondering if I think we use triangle list for a reason because it's easier for circles.
Do we need to use the same one throughout our program?
No, but we would need to have a way to switch between them. So I'm just trying to think.
Could that be part of the instance, maybe, or?
Yep. Yeah, we could encode that into it. Actually, that's a great idea. I think I used triangle strip for circles because it was easier, but triangle strip is more performant from what I remember. Is this true? Should I encode this primitive type into the depend on what I'm rendering. Let's see. I'm thinking probably, because I remember triangle list, it's like super easy this way to do a circle because we can just basically pass it like the middle point and then all of the triangle is theoretically more efficient. However, in practice, difference is negligible. Okay. Pick what's clearest for matching multiple quads. Okay, but would .fbx files be standard triangle strip or triangle list? This is the important question.
What's a .fbx?
So an FBX file is the standard for like importing models into your application. So like it's basically what I'm wondering is how are the vertices aligned in that standard? Because that's the way we should set our FBX files are use index triangle list, not triangle strip. All right, so let's just use triangle list. And then if we need triangle strip for some reason. Okay, adding, removing geometry breaks the strip ordering. Okay, great. Yeah, triangle strip with indices. I remember that. Okay. So triangle list. Okay, great. So now that just means we need to change the, I'm just going to copy what Claude suggested for the, let's look at it. So if you're using triangle list, you need 6 vertices. So, okay, so we define the triangles themselves now. We're not just defining the vertices, we're actually listing the triangles. That makes sense. So for here, it's now width, it'd be like this. I'll just show you how I'm copying, and then you duplicate that middle one, because there we go. And then this point and 0. Okay. That is how we should define our.
So it's like a list of like, it's basically the length is going to
be literally a list of triangles.
Yeah, like so it's going to be like the length of that list would be like a multiple of 3, I guess.
Yes, it has to be.
Yeah. Okay.
Yeah, there we go. That now it's recompiling easily too now. It's weird. I was expecting that to work. Something we can do very quickly just to check if we messed something up. Yeah. Let's logically think through, because I'm forgetting whether we should put this back or front. Like, does this mean it includes front or that it removes front? We would want everything by default to call the back but leave the front. So what's this function do? Rasterize. There we go. I start to assume primitives and fragments using a side viewport and shit. Primitives will be transformed. Defines which side to rasterize. Non-triangle primitives only have the front size. Side. Okay, so front. So it's what side to show. So front is what we want, which means that our circle is the one that's.
Do we probably need to like reverse the order of the circle then?
Yeah, we could reverse the order of the. It's this one here. Triangle verts. Triangulate fan. Triangulate a triangle fan. Yeah, remember last time we did this quite easily by reversing. I'm just trying to think, where did we do that? It would have been okay. So this is the list.
Mm-hmm. Yeah, if you wanted to reverse the list, you could do it there.
I think I would just do this. It's easier than rethinking all of this. Like I could reprogram this to go in the other direction, but it's like
not with the stage we're at, really.
Yeah, and we're creating a circle like we're doing it once. There we go.
Nice.
All right. So now let's make our paddle move. Let's position it and get it moving. So if I were to set the position of this paddle to, no, sorry, go into main, init, paddle is. Okay, and we're gonna put the, where's the paddle start? Oh, here. So it's starting at 0, 0. Okay, so it's positioned based on the bottom left corner. We're gonna want, we kind of want it to be positioned based on the like the origin. Like we should set the origin point of the ball when we're, or of the paddle when we're positioning it. So that'll make it a lot easier mathematically to put it like where we want it. But
like we'll put the ball at the origin or the.
No, sorry, the paddle. Because right now the paddle, it's 0, 0 point for the paddle is right here in the middle of the screen, but so it's the bottom left corner. So it'll just be a little weird. Like we could do it. It's nice to have proper origins on things. We'll see. Okay. Let me see. I want to move this over. First thing I would need to do is just get a better understanding of like the coordinate space. Yeah. I think if I go to -1 here, that should take me over. Yeah, basically exactly where I want it. But now you can see here it's not like centered this way. So the way I'm going to handle that is, so here we put a player start pause, but we want the actual position of it to be relative to this. So yeah, we have to add half of the height. Just thinking of where to do that. Probably in the move function. Or would it be at rendering? Okay, actually, it might be. I'm just thinking of like where's the right place to add an offset, which is kind of what's going through my head right now. Because I want this offset to always apply to the paddle, but I don't know if I want it to be tied to the render, because it's not tied to rendering. It's more around like the way I would do this is I would have an actual function that positions the paddle, which takes in the width and the height,
Mm-hmm.
because that's how it needs to work. And I'm thinking that's probably yeah. Ooh,
Like
okay. I
you're
think
How
talking
does
about
normal
like
mode fit on
I'm
that?
just gonna change this. So I'm gonna change this here paddle. Like the first argument in paddle, or not argument, but this is a pause here. This effectively, like I need this. I need to define a function. Can you define a function in here?
um
It's record syntax, so I don't think you can.
you can, but like, do you want to? I guess.
Effectively, what I want paddle pause to be is not just a V2 float. Well, I want it to be a V2 float, but it should be a function that has already applied these two values to it.
Function that's already applied these two values to it. And
Like pause. Well, no, okay, no, I can't do that because I need that reference pause position. So really, I need some like,
I mean, you could create like a you could have one field be like a function that takes those or something, but
yeah, like, well, yeah. What I need is, so I have paddle position. This is its origin point. Since rendering is, oh no, this is a rendering problem.
yeah.
This is not, I should not be, yeah, I'm just thinking through it now. Should not be touching this at the game level, right? Because this position here is 0, 0. That should be just center. So the problem is that we're
Wait,
not
sorry,
doing
can you
that.
repeat that? The audio is just funky and
Oh,
for the
sorry.
recording too.
Yeah, this paddle position should just be 0, 0, and that should represent the center. Anything else that we add to this code is effectively like we're binding rendering code to game code.
Yeah.
We need it to just be offset by
Yeah, I mean, or like, are we creating a new paddle each frame? I guess, like, where it has an updated position. Like that's what I
yes,
think. Or
yeah, that's what we're doing. Yeah,
yeah,
so like that's what we will do. Uh,
because I guess they're like you're kind of thinking about it. Like it sounds like in an object-oriented manner of like I want to create like a method on the paddle, but really what we need some. It sounds like we need some function to update the position, but we don't necessarily need to do that as part of the of the object itself,
yeah,
right?
well, we're gonna have a function that updates the position. That's fine. The problem here is that the position that we're expecting is not aligning with what we're visually seeing. Like when I say 0, 0, I'm expecting that to be the center of the paddle, not the bottom left corner of the paddle.
I see.
So it's a pixel thing. Like we need to shift all of these pixels down to the origin. But it's really comes down to I'm thinking this is my current hypothesis is that inside of the instance of creating a renderable, this is where we offset this position by half of the height.
Yeah, yeah, and I guess the width too, but
If we wanted to, yeah. Yes. Probably should because yes, we probably should because we're gonna have paddles on both sides. So it would be weird if it was on the like it would be yeah. So we'll do
mm-hmm.
it that way. It's the same. it's the same distance on both sides. So yes, so effectively now, then what we need to do is just add, okay. So pause.
Yeah, because I guess like ultimately we want the rest of our program logic to be with the awareness that the when we say origin it means a particular thing, but then that
Yeah.
that doesn't just translate directly to the GPU, so we need to have in our function a translation of that.
Mhm.
Okay, okay.
And ideally, we just do this once.
Yeah.
I'm doing it here for now, but once we do this like 3 or 4 times and we notice a pattern, we'll.
And well, you know what? This would be where we want to do it, right? Like, because really, it's a translation between like our high level logic of like where like where things are mentally, and like what the GPU is
Yeah, you
expecting.
can do it like you could do it in make rectangle verts, for example, um, or like in the create vertex, like the way, for example, like I'm thinking about like how does Unity handle this? Like Unity just has a default, uh, like a default origin offset, and like it's literally like a point that you can move, and so they just subtract that from the regular origin.
Right.
Um, but that's a
Which is
default
that's
origin. It's attached to every. Yeah, we'll have to think about that, but it doesn't matter right now, right? Ultimately, what we're doing is we're saying the position is the paddle pause, paddle. Wait, where did we do this? Oh, this is gonna be annoying. So we need the X and the Y separately. Um, um, I don't care about naming right now. Let's just see if this works. It's gonna work. So now this is gonna be V2 pause X. I'll just keep the X and then the pause Y.
I guess it'd be minus half the.
Minus, yeah, minus height divided by 2. Oh, PoxX. That's not.
How are we creating verts? Are we is verts is like it's off the screen, but like verts does that involve the oh you still gotta update the um
Hmm?
v2 does not take a tuple, it takes two arguments, but you just gotta change your pattern matching.
Oh, right. Yeah, V2 pause X pause Y. There we go. Now it's centered. We'll just leave this for now. This is something that we could refactor, but it honestly it works. So I don't see a reason to worry about it too much. This basically what I'm saying here is that this code could definitely be generalized, right? Like if we're going to have more things that need to be where their origins need to be shifted, then we can move this out and generalize it. But honestly, for now, it's fine.
Yeah.
Okay, so now we have our paddle, and we are actually, I am going to subtract half of the width as well, just thinking about it. And And then I was kind of overthinking that, and then I just have to change the start pause here to be, ooh. That does present a challenge because I don't know what the width is here. Wait, start pause, that's Y. Oh no, wait, -1. Yeah, that is a bit of a challenge. Okay. Maybe I just don't do that yet until I need to. I'm not sure how I'm going to handle that. Okay, so let's get this paddle moving now. Let's start doing something interesting. So what we'll do should be pretty straightforward. The paddle. I'll do the function in main for now. We effectively need a I'm thinking of a move actor function. And then that function just determines whether it can move, or like whether these actors need to move. It's probably the best way to do it, to be honest. No, because the constraints of whether something's going to move is going to be different for each function. So this needs to be at the paddle level. Or like at the, so say move paddle. This, effectively, I'm just going to sudo this for now. It needs to take our input. Let's make, let me see how we deal with input. So we're going to be using, we haven't done input yet because we got rid of that. We're changing, okay, gpipe, glfw, input. How do we do it? What do we use? Can't find the documentation, so I'm just going to try to see if I can find it that way.
Where would you expect it to be?
Like I've used SDL before, but we moved away from SDL, so I'm just trying to. I think it's GLFW, but I can't remember. Yeah, for input, yeah, it's graphics UI GLFW poll events. Lead events get key. Okay, let me look at that.
Yeah, poll events sounds familiar.
Yeah, this is where all the input is apparently. Let's see
If you hit yeah.
Yeah, perfect. So I could even I could treat. No, honestly, I'll just send in the whole input. That's, yeah. I was just say I'll just send in like the whatever the key map is or whatever, and then I'll have the individual functions just sample those key maps. So let's see, how do we get these are all of our types. Fantastic. Game pads, come on. Lots of deer. Okay, get cursor input mode, raw mouse motion, sticky keys input mode. Get key. So it's the state of a specific key. If the sticky key is name, okay, no. I'm wondering, sometimes you can get like a full key map. It'd be nice. Like a map of maybes. If not, we could create one in the future. Yeah, it doesn't look like it. But I think for now, I'll just sample. Okay. I think right there. Okay, so then if that's the way that works, then we'll kind of just create our own little, like our own little map.
Yeah.
Our own little key map.
Also, too, I'm curious. If you go back to the documentation.
Yep.
And you like check out like whatever we're gonna use. I guess keys. Yeah, get key. How's this like? What's the source of that? Or was
of course.
I wonder. glw get key is like the actual function.
What you're saying, yeah.
I wonder if that's. No,
It's
I don't
a
know.
C function. I wouldn't want to.
Yeah. No, I was just wondering about like creating a whole key map. But because I mean it'd be interesting
It's
to
probably
look at.
gonna like. It seems like really that's what they're doing anyways. Like they're going out one key at a time.
Mm-hmm. Because
So,
I know there's like a reflex SDL, and I'm kind of curious about like in the future taking this and making this into an FRP system, right? Where it's like we could think about it the same way as with reflex DOM, but yeah. So I don't know. I might even look into that.
yeah, I mean you can do pretty like basic game programming with reflex for sure.
Yeah.
Yeah, so I think all I'm going to do here then is just call get key on a bunch of different keys and store their key states in a map. Easy. I'll do that every frame and then just pass that map into. So I'm just going to create data. Or I guess no, it would be. We'll use key state. I guess it wouldn't be maybe keys pressed, released, repeating. Yeah, it would be maybe. This is tricky. No, it is just key state if you wanted to get the moment that you released it. Okay, the reason why I'm a little confused is because different input things work a little different, and this is slightly ambiguous. I'm thinking that this is going to be released when it's not pressed and pressed when it is pressed. But sometimes released can mean like the moment it was released, which is actually what you want in most cases. because you don't really care. Like if it's not pressed and it's not the moment that it was released, it's kind of just doing nothing.
Yeah.
And that's more
I'm.
that's. But
I
it
guess.
seems like they're kind of just giving you the raw, and if you want that kind of system, you have to do it yourself. But yeah, I don't know. I'm not even sure. Like maybe repeating is like you're holding it. Released is the moment you release, and press is the moment you press. I think that's probably what it is.
Yeah. I mean, it is an event too, so it's probably just like telling us when specifically it was released. Like,
Yeah, but
like
my question is it's an IO key state,
right.
so it will always return one of these three.
I guess like my thought is like if like because it's sampling that state, right? And at that moment in time, is it in the process of being released? I wonder if that's what.
Yeah, but what I'm wondering is there. This is incomplete if that's the case. If that's the case, there is no state for nothing is happening.
Well, what is yeah? What was the function signature?
That's
Was it
yeah. So the function to get this is just it returns the IO key state,
not even a maybe? Eh.
not
Okay.
even a maybe.
Huh.
That's why I'm confused. So we'll have to maybe just I think we'll just have to play around with it and see what happens. Like I'm just gonna print out the state, like print out this key state of
Yes.
W, and we'll just see what happens. It's the best way to do it, but I'm not sure. Let's just for now comment this stuff out until we know what we're doing. And down here we will just get the key state. It's going to be get key window. Where's the window? Oh, we store the window somewhere. 1 second. Oh, win renderer is the window. Just say, window, and then the key. What's the key that we want? That's going to be this type up here. So it'll be key. We want W. I think I can. Can I put Sterling in here to lift IO? Right? Okay. That's fine. I'll do that. So it's released, pressed, released. Okay, so it's literally just press and release. What's repeating? I don't know what that is. Oh, maybe repeating is the
I mean,
like for sticky keys or something. I don't know.
well, it did have a note about sticky keys.
Yeah. But okay, let's just for all intents and purposes, we have pressed and released. Okay.
And also too, I get like I think why you're seeing multiple of them is just because it's like sampling, like, rapidly, right?
Yeah, I'm printing it every frame.
Yeah.
That's why.
What is sticky keys, or how does it relate here?
Sticky keys is like literally if you spill something on your keyboard and your keys are sticky.
Oh.
I thought sticky keys was what happens when you press Shift 8 times on Windows.
Yeah, but like, what's the purpose of it? Isn't it for like if you? I thought it's supposed to. Isn't it supposed to stop like things from? I don't know. I feel. What is the purpose? Sorry.
I think it's when you don't have the dexterity to like hold down shift and also hit another button.
Oh, okay. See, I literally this comes from when I was like a kid, always seeing sticky keys. I was like, thinking it was literally sticky keys. That's so funny. Okay, assists users who have physical disabilities or helps users reduce repetitive strain. Okay, so like if you allows modifier keys like Shift, Control, Alt, and the Windows key to remain active after being pressed. Oh, I did not know that.
Cool.
So like you knew Control Alt Delete by doing Control then Alt then Delete instead of
All at the same time.
yeah.
When does it go off then? It's so cool, but I'm curious now.
Probably toggle. You click shift once to enable shift and then again to disable it.
Nice.
Yeah.
Makes sense. Yeah.
Interesting. Well then, there you go. It's not for when you spill something on your keyboard, although that's hilarious. I never thought that.
Yeah, I was like,
Oh man.
I mean, you could fool me with the name, I guess, but
Yeah. Yeah.
my keys are sticky.
You know, like when you press a key and then it keeps going, a. That's what I
Hey.
thought. A. Okay. All the non-Canadians in the room. What the hell is? Okay. Okay, we're good. So we have key state, pressed and released for W. All we need to keep track of right now is W and S. And I would honestly just make this a map of oh shoot. Map of the key to maybe key state. And then I guess I can just populate this, right? Actually, never manually, maybe not in a while.
What's the point of the key map here?
So that we can be like,
Like, is A pressed, is B pressed, right? Like, is that
yeah, that's kind of all really what we're looking at. But actually, no, we don't even need the maybe, so we don't need the maybe anymore. It's just the state.
Yeah, the maybe will be what's returned out of it, right? Whether or not it exists, I guess, or.
Oh, you're right, because the key might not exist.
No. Well, but like that's just like a lookup. Like a lookup returns a maybe.
Oh, right, when you look up in a map, yeah. Yeah. The map itself doesn't need to have that maybe.
Yeah. But I guess then, like, are we, like, how are we building this map? Like, because this map would represent a translation from, like, what we got with,
Yeah.
whether it's, like, key state release or pressed.
So am I thinking it'd be something like this? However, this is, I think that's how they seem to be doing it. So it would be like this. So it'd be like this. Now, like, we're dealing with we have W and S in our map now. Right. And now, like, in here, because in our actual function for dealing with this kind of thing, we're not going to have this context. At least we shouldn't. Like, if we're following best practices, we should deal with all of our side effects kind of at the boundary. So here is where I'm going to get the key states and then populate or like update this input key map. Right. And then everything else will just use this input key map. So that way we're just dealing with this whole impurity in one place.
Yeah. I wonder if it, like, because we're probably only listening to a couple keys, I guess, right? Like, we're listening to W, we're listening to S.
Yep.
Maybe it would make more sense that, like, instead of having it as a map, map, like, the map data type, would it make sense to have it as a record that's, like, kind of acts in the same way, or?
Yeah, we could. Yep.
Because then it might make sense to have the key as being a maybe. Right? Like...
well, no, we wouldn't define it if it... Or what do you mean? Like, this is nice because we can use the same... I guess it doesn't matter, though, because, like, realistically, like, we probably don't want this to be a GLFW key. Like, if we were to be defined, like, creating our own game engine, I would probably turn this into our own key type. But
yeah,
because
I guess, like, I don't know. I mean, how I would, like, think to do this is, like, I just wouldn't... I mean, and this is partly because I don't know what I'm doing yet here, but, like, I just wouldn't even bother with the map at the moment because, like, like, I guess I'd, like, I don't know. I would just pass the keys.
Well, it's effectively the same. Like, it's the same. Like, to your point, I could either go like get key W or something, and this is like this gives me the glfw.keystate.
Yeah.
Or I can call input key map with glfw key, and this also gives me the key state.
Yeah.
Right. So it's like
both would return
they're
probably
kind of the same thing.
Yeah.
Right. One does a runtime lookup, whereas this one's just like assigned to a value. So I guess like this might be more efficient, realistically.
Well, it wouldn't. I mean, not necessarily about
like
efficiency.
It's subtle, right?
Yeah.
It's such a small efficiency.
No, like more just like how to think about it or how to model it, like. Because, both would just be, like, essentially looking up if it's currently on or not, I suppose.
Yeah. We already have the key type, I think.
It would just be, like, really what interface is more convenient for you, I suppose.
Yeah, I personally find this, but if I were to, for example, and that's just because, like, we already have this GLFW key and I can just map on it.
Yeah.
But, like, if we were, when we improve this, I would actually have this be my own like key type, like input key or something, because you can even see this, like it's limited, like these key states, there's only released and pressed.
Yeah.
Something that you often want to do in a game is just when something's pressed, only respond to it once, right? And so like we would want to change this to anytime that you notice that the previous one was released and the current one is going to be pressed, change it to, pressed instant or something like that.
Totally. And you could definitely make a function to do that. Just
yeah, it's very common. You do that in a lot of a lot of game programming.
Yeah.
These input libraries usually don't give you that level of input.
Right. Oh, okay. And you know what? That kind of makes sense because I was wondering, like, would it not make just sense to use, like, even though it's like kind of limited, would it make sense to still use it as like our thing we pass around? But since it's so primitive, we might want to have something on top of it, like our own input key map with our own key type. I guess you're saying, or sorry, key
Yeah,
value
if we're
type.
doing something a bit more, complex, yeah, like right now we're making Pong, so we need W and S.
Right.
So like it's fine.
Right.
But and yeah, we just need to know whether it's being pressed or not. If it's being pressed, it's going to move statically in that direction. If it's not going to move. So it's really simple. But if you can imagine a case where, like, if you're playing a combat game or something and you press 2, but like it should only shoot once, they should have to lift their finger and press 2 again.
Yeah.
Those kinds of things you have to program in.
Yep.
Okay. Key W, key S, GLF W, okay, key window, okay, key. So now we have these, and I'm just gonna say. Wait, actually, this is weird. Okay, so inserting overwrites, that's what I was wondering. Alright, whatever. This can be cleaned up, but I just want to test all this out. Okay, there we go.
You'll need a let keyword there.
Oh, okay. Thank you. Alright.
Yeah, so I guess like no matter what way we specifically do it, we're going to have the I/O step. We're going to create a model, and then we're going to pass that model to make our decisions.
Yeah. Making decisions.
Making decisions.
Okay, so then ultimately now the function becomes actually quite like really easy. Then we'll have to add boundaries and everything, but that's no worries. So now move paddle takes in our input key map. It takes our paddle. And it returns a paddle. pretty easy to think through, right? And this is a pure function now. So it just becomes...
Check if the key exists.
Yes.
Or well, like, okay, so this is what I meant by like the model, because like now it's kind of like we're like those should always exist, right?
What should always exist?
The state of key and the state of the W and S keys.
Yeah, so I agree with you. They're always going to exist. This is messy. We don't want to do this. Also, another thing that I'm thinking of here is like the easiest way to do this is to have a movement speed and then multiply it by either 0 if input is not active or 1 if input is active.
Okay.
The easiest way to do it. You don't have to check anything. There's no if statements involved. So, but that means it's a data structure problem. Like most, and if I'm thinking about it now, most things that I've used, you're going to get either a 0 or a 1. And it's for that purpose. So rather than having like released and pressed, might be nice to just do those as 0s and 1s instead.
Mm-hmm.
So
I mean, what I would think to do, like, it sounds like what you want to do then is you want to make a record which has definite fields for W and S, and then you're just changing the key state released into an integer.
Basically here, yeah, my key state equals int.
Uh-huh. Yeah.
And we're just going to call it key state because GLFW is... So, like, it's just that. So then it's data, input, key map equals input, key map.
Mm-hmm. And now these keys will always exist. And like they should always exist, but now we don't have to deal with the runtime possibility of it not existing.
Yep.
And now we just need to translate from I/O to this input key map, or like our I/O state of. Yeah. Do you use lambda case at all?
Lambda case? I haven't used it, no.
It's so nice here. I'm just gonna say we should use it.
Okay,
I mean,
sure.
It's a syntax.
How would I type it?
Yeah, map key state equals /case. Or I guess is that a slash or backslash? I don't know.
Oh, slash case or backslash?
No. You were right. I'm just wondering if my
backslash.
language. Yeah, and then you would just say, like on the next line, GLF key state released. It's just like a normal case statement now.
Oh, really?
Yeah.
So you can use
this arrow after the slash case.
Yeah. The arrow. Oh, sorry. No, the arrow would come after released. So you'd say released, and then the arrow, and then 0.
Equals arrow or normal arrow?
The arrow.
Huh.
Yep. And that's the syntax. So technically this would be point free because it's like you're not defining the like.
Yeah.
Yeah.
Cool.
But I love it. I love this syntax. Like it's a like, you don't need it, but it is like kind of, it's pretty.
Interesting. Okay.
Yeah. And then you just define your other cases.
Yeah. Sorry, I'm trying to think of what it was.
Yeah.
Pressed, I think.
think it was pressed.
I think so, but we're just gonna.
Now we're pressed to remember.
Now we're pressed to find what it was. I can't.
Yeah, never mind.
I'm just gonna put pressed. It'll tell me if it's wrong.
I was trying to send out a thumbs down for that, but I just waved.
Key state, input key maps. Now we get rid of this.
The
crap.
thumbs down is very, very fair.
Before I forget. Okay. So now then here, we've got our key W and key S. Okay, yeah, this becomes a lot easier. And I literally just redefine it here now. Super nice. What am I doing? I don't know why my syntax is being weird. Like my auto. I normally just do it like this. Okay, there. Input key equals map.
Yep.
Woot woot. That's so much better.
Mm-hmm.
Okay. And then eventually all this can just be moved into a function and away you go. You could probably, yeah, there's some trick there that you could do with implicatives or something.
Yeah.
Yeah.
I mean, we could do that quick. I know how to do it.
You actually know how to do that?
Oh yeah.
Like just off the top of your head?
Yeah.
Like effectively so that we basically just set this from like what's here. But that's gonna be weird though, because like then we're relying on like the order of the operations.
No, we're not. No, implicative doesn't matter what the order of operation.
Or sorry, order of arguments. Right?
Oh yeah, it would, yeah.
Yeah. Which might get messy when you're like dealing with like something like an input map.
Yeah.
Yeah. If you add something in the middle, all of a sudden S is F.
Yeah.
It's probably not a safe way to do it.
No, just keep it like that for now.
Yeah. Cool.
Yeah, like at that point, it would make sense to break it out into a whole new function to do it applicatively, but we'll just whatever for now.
Yep. Okay, so let's just think about our move paddle for now before we look at compiler. I understand. It's because I have this unfinished. That's why everything was like getting confused. Okay, so move paddle, input paddle. Now it's very simple. It's literally, I think we have movement speed attached. Where do we have that? No, we have the velocity for the ball, but we don't have like an input speed. That's going to be a constant across the whole game. If that'd be something that you configure, so I'm just going to toss it up here. Paddle. Or it'd be pi flow. This is also where we need to put it. Bring back our time delta. So we need to pass in our time delta here as well. So now we've got our input key map.
I wonder, does it even make sense to like make the time delta into its own like new type or something, just to like,
It will, yeah.
because like also too a new like I think it'd be a good thing to just demonstrate, because like new types have no runtime effect. They just like are a compile time.
You mean new type or type alias?
No, new type. Okay. Yeah, I'm
Sure.
pretty sure new types have zero runtime impact. It like right they're removed at compile time. Once it type checks. And then
like you have to do like this though, right? Like,
yeah.
Okay, cool.
But at least like next time we come back to like move paddle, we're like, oh, like I know what we're doing.
Exactly.
Yeah.
Exactly. You know what type this is.
Yeah. Especially
okay,
like
so,
with when we're looking at like the math of creating the vertices or whatnot, that might get like complex and hard to read.
Yep. All right, so we've got paddle. Okay. What we need is a movement delta, and it's going to be either positive or negative based on whether S or W are pressed. If both S and W are pressed, they'll negate each other. So,
and if I understand correctly, the only field of paddle we're actually changing is just the POS, right?
Yeah.
The pause.
Mm-hmm. So we go forward movement here. It's just input, or the input key W, or sorry, it's not forward. I'll say upward movement is input key W on input. Times delta. I'm just going to put this times 1 here just so that you can see what, just sometimes I like to put variables even if they're technically just an identity, like it's still relevant, because you'll see, and like if you're good at math, then like sure you'll know that like that this is just times 1, right? But like sometimes I like to do that. Doesn't hurt.
If it helps document the code.
Yes.
Yeah.
Here we go. We've got upward movement and downward movement. And now we literally just, so now it would be movement.
And even too, like if it does end up causing like an optimization issue or something like that, we can always come back to it at that stage. Like,
oh yeah,
we should be thinking about optimization like last for the most part.
The thing is it's so, like, computers are so fast nowadays that like most of this stuff does not matter. You'll never see the performance difference between multiplying by 1.
Yeah.
Like in most cases, the optimizer will probably just remove that anyways.
Yeah, and too, like I mean, just like I forgot. Actually, I completely forgot what I was gonna say. Never mind. You typing something?
Yeah, in Claude. Just forgetting a syntax thing.
Oh. Oh, you would just want to do where you have paddle with the uppercase?
Yeah, I
just
go
change that to
player.
lowercase?
It's yeah, exactly. You go paddle, and then you can open up
Yeah.
this.
And change whatever you want.
Yeah, which is sweet. Except it's gonna have to
Oh,
be in.
let in, yeah. Let that paddle in.
Let that paddle in. Paddle pause. Equals. I only want to set the Y.
If you only want to set the Y, you probably need to like expose the X somehow, and then.
Yeah, I know, or lens, but we're not going there.
Yeah. I was getting fancy with it.
Yeah, but that is probably where it'd be nice to use a lens, right?
Mm-hmm.
Okay. It's not.
This is kind of like a poor man's lens, I suppose.
Yeah.
But I mean, we don't need to be like experts on lenses to get something done here.
Oh. Fantastic.
Mm-hmm.
So now we've got our game state, run the games tab. Oh. Updated game map. And then here is where we call.
You know, I know like both like kind of paradigms say that they do this, but I feel like functional just is better at separating concerns.
Mm-hmm.
You know, like I've like right that must be so much easier to think about than like doing that in like Unity. No, or
I mean, Unity's like, it's not really fair to compare because like Unity's literally purpose built for building games.
yeah.
But if you had something like that built in Haskell, yeah, it would be probably way better.
Well, but like I remember like the one time we were working on a video game and it was like there was like I don't know, like something that was affecting the state.
Yeah, you still have to. There's a lot of state you have to deal with.
Yeah, like you know, you might write something like that, and then but there's like implicitly some other state is being mutated, and then
absolutely.
it looks, it maybe the function looks the same, but like that would be because you're not thinking about state in that case or something. Whereas like here we have a guarantee that state does not affect that calculation.
Yep.
Given that it's pure, I suppose.
So okay, next week we're going to really dive into like the game loop, and because so basically like we have move paddle. Like right now, in order to get this paddle, I have to kind of like manually extract it from the game state, and I think that's what we should probably focus on next. Is basically making it so that like almost like an entity component system where whatever we put into the game, it automatically just knows how to handle it. So if we add another, if we add another paddle, okay, it knows that this is a paddle. This is how a paddle works. If we add another ball, okay, this is a ball. This is how a ball works. Like in theory, you should be able to play Pong with 4 balls. There should be no reason that you can't. Right now, we're very statically defining our game state to say like, okay, we have a paddle and a ball. Paddle is at position 0, ball is at position 1. Ultimately, like really what it should be is something like where we loop, like iterate over actors, call move function with args based on actor type, because it's going to be different arguments passed in, right? And then, then also call collision function with args based on actor type, right? And it's like you basically just say, okay, if any of these actors, like, and for some of these, for example, like maybe something doesn't collide, okay, well then you just make a no collide state, but you still run it through everything, right? And so, okay, if this has no collide, then okay, it doesn't collide, it skips it. This is how a lot of games work, because then it allows you to like model behaviors of the entities in your code. So this is what we'll do next time, is like actually make this code more generic. But right now, I'm going to use the double bang operator to just give me the paddle, because I want to see this paddle moving. So then we're going to go boom, boom, boom. So game state key. Here's my game state. Game state of actors. And then initial game state ball, so it's the second one.
What I'll say too, like one thing I'm wondering about is like if we wanted to build, I guess like it just depends how generic we want to build our system, right? Like we kind of know that we have 3 objects in the 3 objects in the game, like 2 paddles and a ball, and we could easily just like handle those 3 manually or whatnot.
We could turn it into a record type instead of an array. Yeah.
Yeah.
The idea behind that was to figure that out for when we want to add to it, but
yeah,
if we want to just get Pong working, we can skip that.
Yeah. Well, I guess like I'm wondering how we would do a collision system here, even like or I'm trying to think of problems that would happen. So if we were to say, like apply the movement based on input based on the type, would that move both paddles? Like like both paddles respond the same way.
Well, it would. Because if we didn't have some separation of like player and enemy,
Yeah,
which we haven't done yet, right? So right now, yes, like the first thing that's going to happen is it's going to move both paddles simultaneously, but then we're going to add a flag so that it doesn't move the enemy.
right.
And then we're going to define, okay, we don't just have W and S, we also have arrow up and arrow down, and that's the enemy's player keys, right?
Mm-hmm.
And so we can do that. That's not too bad.
I mean, we could always too like I wonder, would it make sense to like have like I'm just trying to think of this as in a class-based system, like pass input key map to every object in the like array, and then that's like a way to, like, what am I trying to say? We have a like if we were defining a class where it takes as input the input key map, and then also like the actor, and then updates based on that. Like we could, we could define it that way, because then we have how each individual thing like should respond to the input key map. Basically, move paddle, but just like move actor.
Well, exactly, and then it's just move actor for ball ignores the input key map.
Yeah.
That's all it is, right?
Yeah.
You can do it that way, which I think is effectively what we would end up doing, right? I think that's what we're gonna have to do. But like for example, the way I would do it is I would have move paddle and I would have move ball, and I would have those be as separate functions. But whatever the input is, I would generalize that almost to like game loop input, right? Because the game loop like the input for it might be that like I wouldn't even I don't know. I guess it's really just game state.
Mm-hmm.
I guess really what we would do is input key map and game state. Really, the two of those give you everything you need to run the game.
Right. And then
right? Because you're either responding to something. Sorry, the functions are either responding to something that previously happened in the game, or it's responding to new user input.
Yeah.
So with those two, like you could even just treat it as a tuple, or just pass those two into the. I would just pass those two into the function. You got the input key map. You got your game state. Boom, handle movement. You got your input key map. You got your game state. Boom, handle collision. Right. That's kind of the way to think about it.
Mm-hmm. So like game state would probably include what collisions happened this round.
Well, it wouldn't. It would include that in the metadata, right? Like you're not gonna like have some array of like. I mean, you might unless if you need to like analyze those collisions, but realistically, like you're gonna have the positions of the things that are colliding and the velocities that were impacted, right? So like the next loop that comes through, it's gonna run all the logic to be like, is there a collision here? Yes, there was a collision. Okay, adjust the velocity. Okay, and then adjust the velocity and then move one frame in the direction of that velocity, so it like bounces off.
Yeah.
Then the next game loop it comes through, it'll notice, okay, no, these things aren't colliding, so just continue along the velocity, but that velocity was set from the previous collision. So like in metadata, yes, it has this information, but it's the functions themselves that determine what the next frame is. Like in every case, the game loop will always just determine what the next frame is.
Right. No, but like where in this game loop do we handle collisions is ultimately like, I mean, like whether or not it's metadata, like what does that
in this game loop? Like we'll do it here. We haven't added collision yet, right?
Yeah.
But it'd be effectively the same idea here as like we would want to move the paddle and move the ball. We move everything first, and then we check for collisions. Right? You don't move one thing, check for collision, move another thing, check for collision.
Yeah.
You move everything because it's one frame of movement for everything. Everything is, that's important. You can, if you don't think about it that way and you try to check for collisions between, between movements, unless there's like a specific reason to do that for some like collision algorithm you're writing or something. That's not gonna work.
Mm-hmm. Because I mean, I fair enough. I guess, I don't know. we're just continually rotating between multiple actions of like check for input, update position, check for collisions, next frame, right? Like
Yeah, and think of like one thing that can trip some people up is like think of one iteration through the game loop as like one atomic, it's not atomic, but like from the perspective of your game, it's atomic, if that makes sense. Like everything that happens, like even if, let's say at the start of the game loop, this is like 0 milliseconds, and then by the time you're like way down here, it's like 0.5 milliseconds or something like that. Like that time is relevant just for the frame rate, but the amount of time here is not relevant to the way the system functions, because what you do is the first thing you do is get the timestamp, and then everything is relative to that. So by the time the next loop comes through, you'll get the next timestamp, but if everything is done correctly, you're doing your deltas correctly, everything should be relative to that. So basically what I'm trying to say is your game loop becomes like it becomes your clock, if that makes sense. Nothing within here, like everything within here is like one atomic step of your game. You don't want to be like checking things like within the game loop. Like you want to prepare the game loop for the next time the loop happens to check if something has occurred.
Mm-hmm.
Okay, so we've got move paddle, updated input map, pad.
So then, like, sort of question with that, like, wouldn't we want to do our collisions, like, right before we render the scene? Or...
No, we would want to do our collisions before we move.
Right.
Or yeah, like we do it before we move. Like we calculate the movement, then we check collision.
Yeah.
And then we apply yeah.
So I guess then, like, that function we just wrote of move paddle, that would take as input to whether or not it collided with something, right?
Move paddle. Well, I mean, the paddle doesn't care about colliding. The ball would.
Yes. Sorry, that's what I mean.
Yeah. The paddle is just a thing that can be collided against, but the paddle doesn't respond to collision.
Yes.
Okay. Let's see. Okay, so if I get this new paddle now really all I need to do is update game state.
Also, too, because we're working with a Scolum type, you're not going to be able to do that index of 1.
Sorry?
You're not going to be able to get back the paddle that way.
Oh.
So because we've gone this way through existentials, everything that we're going to need to apply to that like array is going to need to be through a class.
Mm.
So we're going to need to which doesn't really make too much of a difference.
Yeah, that's fine actually. That actually makes sense.
Yeah. So we need to make move actor, which will, like, in the same way, just kind of like delegate.
I see.
Yeah.
Because this gives me type actor, and there's nothing I can do about that.
Right. You can't recover that. You can't go from an actor to a paddle. Right.
Yeah,
that is impossible to write that function now.
Yeah.
Now you need to keep it as an actor, but keep it as a how do I say this in English? Like you can apply an interface which will work, but it needs to remain an interface, I guess. And that's just dealing with existentials. It's like we know, right? We like with renderable, we've said that like it's something that is renderable, and now we are using that renderability, and so we can do it that way, but we can't go and get back just like a free variable, right? We can't go and get back a paddle and then do stuff that is specific to a paddle. We have now made things polymorphic, and so we have to respect that step of making it polymorphic, right? We can't go from being polymorphic to being specific.
Yeah, no, at least not without having that interface.
Well, they're like,
Or well, no, you can't in general. The interface specifies that like at compile time choose which implementation.
yes.
Okay, so then ultimately I need like a movable type class,
Yeah.
and then collidable and whatever. And this is where we get into components, like almost like treating these elements as like components.
Yeah.
So if I go class movable, I'm pretty new to writing type classes, so bear with me.
I think you just want class movable A where.
Yeah. And then we need to, honestly, I'm just going to create move, like write move.
Yeah.
Move is going to take whatever that A is. It's going to take our I'm wondering here now. I guess it would take our input key map, right?
Mm-hmm. Input key
And
map.
time delta.
Yeah, time delta, and then the A itself.
Yeah.
Whatever A is, yeah. So I guess like maybe the English way of saying this is that we can use classes to resolve a polymorphic type. Like that's the only way to work on a polymorphic existentially quantified type is through a type class. Like that has the because it's really just a compile thing, I guess, at that point, right? Like,
Yeah.
Yeah. What's movable? I don't.
I'm
think
almost wondering now too, like you might, or sorry, no, what's movable?
Yeah.
I guess no, you're right.
You just want an A.
It would just be A. Yeah. Okay,
And so
there's
we already have an instance of this, which is just move paddle.
Yeah, so we'll just we'll change that around. So instance of
movable paddle.
Oh yeah, and then we're gonna have to have our movable actor, which calls the gotcha. Okay, so instance movable paddle where, and then we just change this to move.
Well, I mean, you don't even have to do that. You've already like I would just
Right, go ahead.
You don't have to like change that writing. Like you could make move paddle like you could keep move paddle as is, but then just call like move like equals move paddle, for instance.
Sure, but then like okay, maybe, but
I don't know. It's up to you. That's really style at that point.
I feel like when are we ever going to use move paddle when it's not in this movable class?
Yeah, fair enough. You're not going to use it.
Yeah, I think about it. I think is like if we're not like I agree. If we're going to use the function elsewhere, we could do that.
Yeah.
So I don't need to specify this here. I just need to make sure that this is correct.
Yeah, correct ordering.
me change the order. So move, input, time delta, delta, paddle. And there you go. So now we've got the movable paddle.
Mm-hmm.
So now we should, in theory, be able to also do like this.
Yeah. And also, too, we're going to need to change actor to have multiple type classes, so not just renderable, but movable. On a couple lines up on 33.
Ah, yes. Yep.
Let's put the brackets.
Yeah, this will need to be brackets now. Okay. And move, and we're going to say this is input, time delta, A,
Yeah.
equals move input, time delta.
Yep.
Easy.
And then we'll need a movable of ball.
Oh. Ball as well, yeah.
Yeah. Although it'll probably just toss it out in that case, right? Or
Yeah. Well, I guess, right? Yeah, yeah. So this is like movable by like the player input, not just like it can move.
yeah. Or yeah. I guess maybe the type class name it needs to change.
Respond
Like,
to input.
yeah, input listener or something, or yeah, response input. Yeah.
Because then we can have move, we can have like other things that it does, right?
Yeah. Maybe like I don't know. Yeah. I don't know if we changed the function name, but it doesn't really matter.
Yeah, move. I mean, move is fine because move is one way to respond to input, right?
Yeah.
But at least this way, like we're specifying that like, okay, like ball. But here's the thing, ball doesn't necessarily, like there is no case where it makes sense for a ball to respond to input.
Mm-hmm.
Well, but we're saying because it's an actor, so we kind of have to just default this to nothing, or what?
No. We just return itself.
Yeah, I know. I guess.
Yeah.
That's what I mean, though. Is like we have to add this instance because it's there.
Yeah. Well, it just has to the compiler has to
Yeah, I understand that part. I'm just saying from like a design perspective, like it's a little weird that we're gonna have like. I guess it makes sense though because there's some ways in which these are the same and some ways in which they're different. And so when they're different, we have to default the case that because this case has no meaning, right?
Yeah, you're just doing nothing. You're just it's like a pass.
Yeah.
Because we're going to call this on the entire array.
Yeah.
And so it's like, okay, well, what do we do when we get to this case?
Yep. No, this is right. I was just trying to think it through.
Yeah, it does look weird, but and I've never done anything like this necessarily, but just thinking through because again, it all comes from what the compiler.
Yeah, and it'll make a lot more sense in a more complex game. Right now, we've got we've got two paddles and a ball. So.
Yeah.
Okay. Updated game state now just becomes.
Updated game state would just be, I guess, calling move on all the functions, right?
Yeah, exactly. This has to change now. Yeah, really, it's just the new. It's updated actors effectively.
Yeah.
Which could just fold, or like I guess just fmap move over the yeah, you can just fmap move over the actor now.
Yeah.
Damn. Okay.
Yeah, because we have a list of actors, and so yeah, we just yeah.
Yeah.
Yep. And do we have our instance of movable for actor? We do, I think.
Yep.
Yeah. Okay.
There. I mean, if once this compiles, should allow us to move. What's this? 206.
Maybe just indent.
Oh, I shouldn't have to indent that much, no?
Oh, just same thing, I think. I think it's just the let syntax.
Mm.
The let and do syntax more specifically.
Oh, wait, yeah, I think I normally go in the next line. Yeah, I remember I normally go like this for that reason, so that I can.
Yeah.
I don't know. That's weird. Normally I can just go 2 spaces over and that counts as an indent.
I'm not sure. I don't know.
Whatever. I'm not going to question it. Oh yeah, we didn't change that to response to input. Ah.
Oh yeah, that makes sense. You change the class?
Oh, I didn't change the here. I changed the instance above it, but not the class.
You mean response? It's a response to input. You just got the.
Ah. Thank you.
Nice.
And then yeah, one more thing.
Oh, you just gotta apply the other arguments to the move function. Move needs the time delta and the input key map.
Yeah.
So just partially. I guess this would be a partially applied move.
Yep.
And then we map it to fully apply, or it becomes fully applied when we map it over the list.
Yep.
Oh, and then time delta, we just added the new type. So just wrap the time delta in a new type, I guess.
Can I just...
Well, and then you would need to add the wrapping.
Yeah.
Now it's gonna complain that it's actually a time delta.
Sorry?
Now it's gonna complain that because you're labeling the type, you're doing an explicit type annotation.
Oh, I see. Okay. Yeah, I'm just doing something wrong here. 186. Expected float got key state. Okay, something wrong there. 186.
Is time delta maybe, or what's the new type of time delta? Or what's the definition of the new type? Is it
It's a
int or a float?
Float.
Oh, okay. And input's a integer though, right? Input key W, we change it to an integer, so we could just say from integral on that.
Oh, I see why this is. I see why this is an issue.
Yeah, time delta
Oh
is a
yeah.
float. Input key W input is going to return an integer, so we can say from integral on the. And we're going to want to do the same with the other one, downward movement.
Alright, less errors. Match expected type actor with A. This is like 38.
How do we do that for renderable? What the? I don't really have any.
Well, because renderable. Oh no, yeah, no, you're right. Move. That would have given input.
Oh wait! It's because we're returning, So okay, this is exactly like what I was saying before, and we're just accidentally doing it. Is we're like move is returning the case of that actor. We need to rewrap an actor.
Like this.
No. For specifically actor, we just go like put actor before move. Like how am I saying it? Like the equals actor.
Oh.
Yeah.
Oh yeah. Yeah.
Yeah, because otherwise it is correct. We're returning some polymorphic A, which is impossible. You can't just return like a mystery type.
Yep. Surprise.
Yeah,
Making decisions.
making decisions.
Okay, 206.
Oh, what the heck?
Wait, what?
Yeah, what?
So it does give us a maybe? What is this bullshit? No. Something that we're doing is.
Check the like put brackets. Okay, do a typed hole on get key. Like that's the most definitive way to figure this out.
Yeah.
Like, and then yeah.
Could be. We could have been looking at an older version.
Yeah. And then let's look. It returns a maybe.
It does. Wait, what?
So I guess we could say, like, we could. I don't know what the maybe is supposed to represent.
Yeah, because we were printing it out before, and there was no maybe. There was no. It wasn't saying just. Was it?
Maybe it was. We just never realized it.
It was.
Just key state.
Yeah.
Was it ever a nothing?
I mean, maybe right at the start. Like. No.
Huh. We could always like. I mean, I guess we could just have a from
Let's just
maybe.
do like from maybe and default it to released,
Yeah.
right? Because I don't want to deal with the maybe. Like, let's just
You could do that in map key state. That might be a good place to put it.
actually, yeah, that is a good place to put it. I like
And
that.
then maybe gleft keys, and we can expand on our
Lambda case.
lambda case. Yeah. So those would be just in those cases, and then a nothing case.
Wow. Okay, it's literally that easy.
Yeah.
That was trivial.
Trivial.
All right. Non-exhaustive pattern matching.
Oh, just repeating. You can handle that.
Oh, you're right. Yep. Very good. Very good. Thank you.
Very good.
Very good. Very nice. Very nice. Repeating, I have no idea what that means. We're going to treat that as a 0. Until we have a better understanding of this, pressed is the only thing that...
Yes.
We'll just look at that first. Pressed is the only thing that gives us a 1.
Uh-huh. Nice.
All right. Now it doesn't do anything, but we're getting somewhere. There's probably just something that we're missing here.
Yeah. Well, probably our logic just needs to update, but
Yeah.
that might be a good place to end it.
Yeah, it is probably a good spot. And I know why. I think because the updated game scene. We're not up to, we need to pass the new state. Like, I could try this and then we'll call it.
Yeah, do that quick.
Okay, see if that does it. Oh wait, what's this update scene? We got rid of that function. Might be oh okay, it was relatively straightforward. Let's see if that still works. No. I'm not gonna overthink that. All we need to do is just set the we need to set the game scene of the scene. So if I go to or set the game state in this scene object.
Yeah.
Yeah, it's getting the renderables. Hmm. Yeah, it's tricky. Yeah, we're over time, so. What were you gonna say again?
Yeah, we're definitely just not passing forth the updated variables to render, maybe or something. I don't know.
Yeah, we need. Well, what it is we need to update the actual origin. Like we're updating the position of the ball, but we're not translating that position of the ball through to the renderer.
I see.
Because we're just passing this old scene. Like the scene is what actually renders the game state. And honestly, I'm thinking about this now. We might want to kind of think about this a little differently.
Oh, okay.
Like the scene itself should just render. Like we shouldn't have to update the scene, if that makes sense. Like we should be able to just pass in our game state. Actually, yeah, I guess that's what it was doing. Yeah. Like there shouldn't. It's almost like shouldn't really be updating the scene. It's like it's drawing a scene from the game state each time. It's kind of a way to think about it. So we should probably just have like a create scene function and just have that taken the game state.
Yeah. Well, maybe, yeah.
That's good for now. I'm going to put this here.
Yeah.
Effectively what we need to do next.
Facts. Good idea. Peace
There
out,
you go.
Sergio.
See you later. Please push on GitHub. Will do. All right, cool. Yeah, that's that. That was fun.
Yeah.
I hope you learned something there, Galen.
Hmm?
A little bit of game dev.
Mm-hmm.
I was thinking when you were talking about comparing Haskell to Unity and how like, oh, wouldn't it be nice if we actually had some like Haskell tooling for building out something like a game engine?
Yep.
That would be mighty neat if someone was building that.
It would be, wouldn't it? Galen?
I mean, there are some.
There was one you were telling me about the
Yeah.
other day.
Gangan looks interesting. I think it's alt-roams / Gangan. They've been working on it for quite some time now. They got a bunch of examples that you can run, and yeah.
Yeah, we're probably gonna look at using this in the future once we like build the engine ourselves.
Yeah.
For learning perspective, like once we get to that point, I'll be like, okay, well now we understand how game engines work. Let's use this one.
Yeah.
Oh, cool. So we are actually deriving the knowledge of understanding how a game engine functions from a practical perspective, and then pulling in the heavy artillery.
Yes.
Yeah, exactly.
Cool.
Because it could be some of these things, some of these concepts, like when you're going into a game engine, especially a game engine like this, where it's just a code-based game engine, like there's no like, it's not like Unity where you can whip it up and like you can see the coordinate system and you can like drag things around, right? Like if you don't know at least a little bit about what you're doing and you were to open up something like this, it could be pretty overwhelming.
Yeah.
This game engine is built for people who have worked with game engines. Like you can tell just based on the way they're documenting things. Like it's like if you don't know what a shader is, like have fun.
Yeah.
So yeah, that's kind of the approach we're gonna take. Is just discovering all these things for ourselves, learning how they work, and then yeah, we can go on to like an actual game engine and start like that would be where it would be kind of cool to. That's where we can get into like more intense physics and stuff. Like we can do different physics simulations and whatnot. But we can do it in our own engine too. Who knows? Like we might get this.
Can we simulate particle collision?
Pardon?
Can we simulate high-speed particle collision?
Yes, I would love to.
Let's simulate a hadron collider.
Like I'm not kidding. If you want to do that, if you want to, like it'll take us time, but like I would love to have.
I have no idea how it would possibly work because I'm talking about.
No, neither do I. What I was thinking is like just from a graphical perspective, we can have them shatter off of each other.
Oh, that would be kind of cool.
But like, no, like if you want to talk about like the actual modeling, the actual collisions of particles, I mean, we could get there. We could do a simple version of it. Like if we like,
no, definitely not a priority.
No,
I was more thinking of like, I don't know. I was
something on a smaller scale. Like I think like something like that could be cool. Like the way I look at these kinds of things is like, if we're not on the bleeding edge. Like somebody, like there's probably like some kind of particle collision that's like really like documented, like well documented nowadays, that you could just like create some kind of simulation out of it if you wanted to. But I would more treat that as an exercise of like taking some like crazy domain and then like scaling it up and making it work. You're not gonna. It's not like you're gonna go and pitch that to CERN, right? But it's just like you've got at least some of the like thinking practices would be there.
Yeah. Well, I mean, I see the stuff that you're building here as useful within the realm that I've been looking at. I think I've mentioned it a time or two, but basically compiling OpenGL directly for the browser.
Ooh.
Because if you really want to avoid writing JavaScript, I don't think the answer is to write something that compiles to JavaScript. I think it's to write something that compiles into WebAssembly.
Yep.
And actually build OpenGL powered interfaces.
Okay. Love it.
That'd be fun.
It's possible. I was looking around, and you need to use some JavaScript as a shim, but
yeah, I mean some JavaScript's fine. It's just yeah. Yeah, that's interesting actually. Is there no one like looking to do that right now? Like I mean there's probably gotta be.
With WebAssembly?
Like rendering OpenGL directly to WebAssembly. Or compiling it directly to WebAssembly.
I feel like there's something like that. Maybe, I don't know.
It seems like it's still like bleeding edge. Like it's
I mean, you can do OpenGL in the browser for like certain things. Like I don't know about the whole, like if it's done for the whole browser, but like you can do like a, I don't know if it's like through a canvas or something.
Yeah, that's how you do it. You just basically have the entire page be a canvas,
right,
and then you render it with OpenGL.
Yeah, I mean, no reason you couldn't do that.
Yeah, I think the cool thing about that is that then you can actually build apps that work both natively and in the browser.
Right.
Much more easily than having some complex derivation to convert all the logic into JavaScript.
Right. I mean, yeah, you would just have full control over like the UI. Like you wouldn't be constrained to like how HTML and CSS and all that works. So.
Yeah. Because I don't know how, realistically, I don't know how long the web browsers are going to last. Just like the way things are. I don't know. I am continuing to build a lot of stuff in HTML and CSS because it's comfortable for me. But I think that at some point I'm going to want to cut the browser out of what I do.
Yeah.
Yep. I think a lot of people are moving, like, I don't know. It's going to be interesting. It's going to be interesting as we move into different, like, we move away from phones into, like the glasses and, yeah. I feel like, though, you still will, like HTML could still be used. It's just a markup language, right?
Yeah.
Like,
I feel like even the browser.
Why you wouldn't use HTML on like, Meta glasses or something, like unless they have their own protocol. But
yeah. I definitely agree that like the way that we interact with the browser will like change, but like I think the browser itself will always just be there still because people are, people don't want to change technology that easily all the time. Like there's gonna be people who are like, let me get Meta glasses and I'll never use a browser again. But like, or like now it's a different type of browser. But like I don't know. I feel like the browser interface is like always going to be important just for like people who don't want to deal with new tech. more so.
Yeah, agreed.
Yeah.
And what I'm looking at is kind of a different perspective. It's not about new devices so much as like Firefox is hurting right now as the number one competitor to Chromium based browsers.
Yeah.
And if Chromium ends up with a monopoly over the browser space, then you're going to see, I'm expecting maybe as a worst case scenario, but more like I'm expecting that Google would pass some stuff that's similar to what they're doing with Android phones right now, where apps have to be approved by a Google license.
Right.
Then you end up with a whole you need to have like Google approved web pages for them to work with Google Chrome, etc. Which, like I said, worst case scenario, but I'm ready for it.
Yeah. Yeah, no, I'd definitely be cool to see, like, I don't know, there's, like, yeah, I'm so curious even what the other issues with, like, Firefox have become, like, because, I know there's, like other, yeah, there's other issues, and, I don't know, I wonder if it's just, like, it's not maintained, or, like, as well as it used to be, or, I don't know.
Well, I could draw parallels to Haskell, and this is like I still use Haskell. Obviously, I'm here. I'm building stuff in it.
Yeah.
However, I think that GHC has become the like half the packages on Hackage use GHC prim. So it's effectively impossible to build Haskell outside of the GHC environment, which is why you can't use things like hugs to a high effective degree, because they don't, like, the packages just aren't available.
Well, like, what about, like, micro HS? Like, is that, like, you can, because
That was a similar thing, right? It's like I wanted to use it, and then because it's built from scratch and it's not built to work with GHC prim, a lot of the stuff is not like you just can't import the packages effectively. You can write Haskell in it, but you can't use like 70-80% of Haskell libraries. This is actually in the micro HS documentation.
because of GH. Okay, huh? Like like, sorry, what is hugs in this context, or like why would you want to use Haskell source code with hugs?
I just mentioned hugs because it's the previous, like it's directly compilable from the C compiler.
Or like what is it like?
Hugs, it is an interpreted. It's like one of the other most common Haskell language interpreters.
Oh. Okay. Yeah, sorry, I'm just looking at it. I see it's like deprecated though, or
Yeah, so when people talk about bootstrapping Haskell, usually this is the point that they consider jumping from. Because that's like the last known commonality between GHC and the Haskell world at large.
I mean, like, well, like, I guess where I'm confused is like Haskell kind of, or sorry, GHC is kind of like the like meant to be on the
GHC is
compiler.
Haskell at this point,
Yeah.
but a lot of the stuff that is defined in GHC prim is not Haskell, right? It's GHC.
Well, even like GHC prim is in Haskell, or to my understanding, if I could be wrong about that, but like it could be C code, but wouldn't it still be Haskell code, or?
Yeah, well, it's a superset of Haskell, right? But when you build on GHC primitive as a base, and the only things that can use GHC prim are GHC, then it creates a sort of a dependency, right? Which is something that like I'm building all my stuff in Haskell still. It's not a make or break type deal for me.
Mm-hmm.
However, it does make me cognizant of like the ongoing updates and adopting new standards. In the same way that like the web browser, like every new standard that is put forth by Google Chrome or Chromium
Yeah.
that becomes expected is another thing that the Firefox devs have to build to keep up.
Gotcha. Yeah. Okay. I see what you're saying. I mean, you are still able to just do Haskell 98, like with the newest like GHC stuff. Like, like because my understanding is like Hugs only supports like Haskell 98, and um yeah, like I guess I get what you're saying of like I don't know if it should necessarily break old Haskell code. Like I guess what I'm trying to say is if you can compile something with Haskell 98, you should be able to compile it with like the newest like GHC 912, which like has GHC 2024 enabled by default.
Yeah, I think you're right.
True. Yeah, I think I don't know. I think Haskell's like done a pretty good job of that, of like not like breaking old stuff. Like it seems like it's very good at like um just keeping like very stable, like very very. I know like there's been people who have like been frustrated with like the fact that it like if you want to update like something in Prelude, it's really hard. Like it's almost easier to just make your own Prelude than like to change the Prelude that everyone uses, because like they want to keep the API just like very stable. Yeah, so it shouldn't ever be a problem with like using old or using a Haskell 98 subset or superset or yeah.
Uh, su- uh, yeah, Haskell 98 would be a subset of Haskell 2025.
Yeah, yeah.
I think that the thing that I'm coming around to a bit about Haskell is that it is good for prototyping. Like
yeah.
the stuff that I'm building out is coming along, and it's helping a lot to refactor things in ways that make sense. And ideally, I'm really hoping I've been working on something adjacent to project number 3, but kind of like I'm trying to implement everything that project number 3 requires, but I'm trying to do it in a way that I'm actually going to use.
Yeah.
So I'm not using Obelisk. I'm just kind of building stuff from the foundation that I've been working with.
Yeah, and there's no need to use Obelisk, right? Like it's just one option. We'd recommend it, but like that's just kind of like what most people would want to use. So yeah, might as well use whatever you want, really.
Yeah, I'm building a rendering engine that basically takes HTML and parses it to optionally include social data, like a list of posts, etc.
Yeah.
I mean, you saw how I was approaching Project 2, so kind of an extension of that.
Right.
But
Right.
I'm hoping to get this done in the next couple of weeks. I've been banging my head against it for a while now, but would be cool to like once it's in a stable spot to have you guys look at it and
100%.
see how it do.
Yeah, I'd be very interested to see that, and feel free to always like ask questions, in the chat and shit too. So, yeah, like honestly, like with our community, like not a lot of people reach out for help, and like that's kind of like the point of us being here is to help, with like just different weird oddities of Haskell. So because there's just so much information to take in, right? So always happy to help with that.
Cool. Yeah, I think I have been like a lot of it is just moving the existing knowledge I have into a Haskell format, which
Yeah.
is a lot of trial and error, and just kind of like finding out, I guess.
Yeah, totally.
But
Totally. Yeah,
once,
like probably not like a point where you're like necessarily stuck so much. It's just like you kind of know what you need to do next. You just don't know if what you're going to try next is going to be the thing that works, I suppose.
yeah, and once I have the foundation laid out effectively, I think I'm going to be in a much better place um, to reach out and share it and to ask for input.
Gotcha.
But it's kind of like, I don't know, what's a good analogy to draw? I can't think of anything, but
Yeah.
my main .hs was previously a like 1,000-line monolith, and I'm currently separating it out into actual libraries so that the information can be digested piece by piece rather than just being all there at once.
Gotcha. Yeah. Makes sense.
So I think once I boil that down to the simplest possible, once I distill it into something that is relatively pure,
Yeah.
And not messy, then I think it'll be much easier to convey the information and ask for input and to see how stuff could get built on it.
Right. That makes sense. Sorry, I should probably get going. Just have some plans that I'm a part of for the day, but that makes sense. Always happy to talk more about it over chat or something. But sorry, I definitely should get going.
All right, cool. Well, thanks for the lesson, Kyle. I too will dip.
Yeah, peace out, man. I think Kyle's left his.
He's outie.
Yeah. All right.